we started from scratch, from database creation to data synchronizations to the modeling steps that we developed using different softwares. But now you already know a lot of processes. Okay, that susceptibility, hazard, vulnerability, and risk. So once we go through this application, we can be able to understand. Okay, step by step. So this lecture, I am going to give you a brief introduction to the flood, try to understand the different types of flood. Then, how we can use this technology. I think we can skip that part because we know that these GIS and geospatial based techniques are being widely used. And then, the detailed methodology of the flood risk assessment. Okay, because once you go through this process, obviously, you can apply similar kind of approaches for different kind of geohazard applications as well. Okay? Well, we know that flood is a very, very serious hazard. Okay? And if you look at the report, what is going on? If you look at the report, so among all the disasters that happens, about 30 to 50% of the disasters occur in floods, especially because of the hydrometeorological patterns of floods. Because we have every year the recurrent occurrence of floods like the seasonal floods, during monsoon time, flash floods, and so on. Okay, but again I would like to mention here, depending on the type of flood, obviously your input data is going to vary. Okay. Always remember, your data is going to vary depending on the mechanism that it takes. It's not just any kind of flood, you take any kind of data. Okay? Clear? So now let's look at the different types of flood. All many of you have done civil engineering, also in hydrology. So obviously, you know that there are different zones that has been classified, right? How the water basically flows across the terrain. Okay. You have zone 1, which is the headwaters. So this is the mountain. See, this is the mountain area, right? This is the mountain area, and this is the delta area. That means the river is going and meeting the sea. So this is the place where the origin of the river. Let's say, for example, Ganges, the Ganga, Brahmaputra, all those. Okay, all those rivers. So the entire this area is called the zone 1 or headwater. What happens here? Very steep slope. So obviously the water crosses through very quickly, right? That means the surface runoff is very, very high. The infiltration is low, right? With not much time to infiltrate through the soil, okay? So mostly you have the V-shaped valleys, right? Go actually to one of these areas, you have V-shaped valley. Then now, all these small streams comes and then mix and then mix in. Like in the case of Ganga, then you have Alaknanda, right? That's why they meet and then become Ganga, isn't it? And how many of you have visited? Okay. So many streams come, they meet and then actually make a big river. So then the zone 2 is called actually the transfer zone. This is the transfer zone. That means it is a very low elevation area, right? It's the foothill of the foothill. Okay, it's very gentle slope, and this is the place where the river starts to meander because it's gentle slope. Okay, then you have the zone 3 where this gets deposited flat surface. This is where we can say after Pradhan, once you go down to Uttarakhand, Uttar Pradesh, and once actually the Ganga flows through, and finally here, this is the place where we call Bangladesh. So this place is what we call Bangladesh. They don't call Ganga there, they call Padma River. You can get actually the most expensive insufficient. Bengal is good, more definitely. Okay. So this is the depositional zone, obviously, and this is very, very fertile, obviously, because it brings down all those sediments, the nutrients, and everything of the soil. Soil is life, as I mentioned, right? That is why this mission by Sapur right? Soil is life. Because no soil, you can't do anything. Right? You see, yesterday I went to Pradhan. So when we were driving through, you see there is a lot of dry land. And there is definitely a lot of water issues in Dhanbad. I have never visited that country because I didn't know how the landscape is. So now you know this is a very, very fertile area. But again, it brings some other kind of trouble as well. Because once you have a lot of depositional, that becomes a flood-prone area. Okay? Alright? Understand these three things? Now, whereas you have, okay, flash floods happens basically in the zone 1. Because rapid, quick, okay, bit of rainfall, the rainwater crosses through, precipitation crosses through, and then the flash flood happens. So flash floods basically, they have very different kind of characteristics. They are fast, do not have much morning time, singular events, it's not multiple events, very short, mostly you have the mud and very flow. Okay? Right? But where is in the case of the seasonal flood, it's totally different. That means the bank of the river gets swollen, right? And then obviously the flood spreads. That's the river flood. Then also you have the coastal flood as well. The study area that I'm going to show you here in Malaysia, it has a very unique characteristics. That means you have actually the coastal flood, the seasonal flood, plus there is actually the storm that is coming from the sea. That means in a normal situation where the river water is supposed to be drained to the sea, but during that period you have a lot of storms, so that you can't discharge. Because sea water is also intruding into the river. That's why actually the dam gets flooded. Obviously the normal flood scenario also occurs. Okay. Flood mapping, basically you know there is a traditional way of flood mapping also. That is why we do the hydrological modeling, hydrodynamic modeling and so on. Essentially we calculate the Q, the discharge of individual basin or catchment, and then based on that actually they calculate how much of water level, the predicted water level. That's a traditional way of doing it. Now, okay, so Malaysia is very prone to floods every year. And normally because it's a tropical climate, right? As I mentioned, 2,400. I'm just sharing you some examples from Malaysia, but I could have also shared from any part of the world because I've done work on different parts of the world. Okay, Bangladesh, Korea, India, but it's just that from A to Z, I want to show you the total process flow. Okay, so you can see that every year they have floods. 2006, 5, 7, you know. Then also there was a massive flood that happened in 2015 as well, which caused $5 billion. Okay? Again, why this happens? Previously they never used to happen because unplanned activities and also converting actually the normal land into concrete. Right? So the infiltration is becoming very poor. Basically it's a lot of runoff. So as the surface runoff is high, then the because of the sedimentations and clogging of the drainage, the water cannot be discharged. That's how it gets. Okay. So, and this I can skip. This property losses of within $100 billion, but I think it's the same case in Malaysia. Maybe in the excess of more than this amount. Okay, every year. Now, if you look at the disaster management program, I have also taught you the cycle. Remember the disaster management cycle? DMR. Okay. Now, what are the process flows? You have that acquisition, depending on what sorts of data, depending on what kind of geohazard or disaster that we are addressing, data processing. Again, this is critical because of knowledge as well as the resources you have. Same thing also goes here as well. Data modeling, data processing is a big step by itself, right? Uncertainty the data, understanding the data, creating your spatial database, creating your attributes, correct attributes, cleaning your database and everything. This is where it is done. Then you have the data modeling. That's what we are learning. Different type of models, you know, and so on. Then finally we do the information. So when the government wants actually your output, so the entire package should be done as quick as possible. That means from database acquisition to processing that, then modeling, forecasting, then dispersing actually those outputs of the outcome of actually your modeling to the people. Otherwise it's useless, right? Obviously for academic purpose you can write a paper. But when you want to translate actually how it can be useful for the local people, that is where actually dissemination of the information is very important. Because in disaster handling, the most important thing is preparedness and readiness. That is where actually you use the coping capacity. Increase your coping capacity and build up your resilience. Remember, there are many terminologies I have taught you. Alright? Then all this information that at the end output should be distributed in a real time. Ideally speaking, this is what we wish to do. But sometimes it's very hard to achieve because maybe during the monsoon time the railway stations are not working, some of them are faulty, some data comes that is all problematic. So all this you have to also analyze, making sure each data actually is accurately being captured. Okay. Now, so if you look at because we established the system, including the early one, so therefore I am just teaching you the entire operational framework of the system. Okay? Most important thing is here, spatial based detection and monitoring. So what are the input data you have? Satellite systems, airborne systems, and ground monitoring systems as well. Right? Depending on the type of geohazard, but obviously in this case we are just focusing on floods. Okay? So all this data comes in from different agencies, then you prepare actually the database, spatial database. Okay? Shape file and all those raster files and image files, all those information comes in. There are two types of data that we are looking at if you want to do the disaster management. It's not just actually the forecasting or modeling part. Another part actually is also how? What is that? The disaster operation. Let's say if in the case of a flood is occurring right now, how the government or the agencies can address this issue, can mitigate. And in order to do that, obviously we need the disaster operational database, such as evacuation data, right? So you know, all the database about the evacuation, for example, most likely which are the location of the places that people can be evacuated. What are the limit of those? For example, there's a school which can accommodate about 200 people. Now you put that on 1,000 people. There will be another disaster there. Okay? Right or no? Kalam gave it was disaster. Lucky I'm alive today. I thought for a while I would die. It was a disaster. It's total mismanagement of the country. Okay? इतना बड़ा दरवाजा उसके अंदर थोड़ा 4 लोग इसमें. What is the meaning? For a while when you are queuing up, you don't know there is no evacuation. Let's say an old people are sick. What do you do? There's no way that you can evacuate the person. I think twice we thought we were going to die. I thought I was going to die. That's scary.
Happy दर्शन में?
हाँ?
Happy दर्शन में बोला?
Happy दर्शन में 2 घंटा लग गया. और हमारे पास सिक्योरिटी भी गए थे. हाँ? 4 लोग हमको लेके गए थे. बताओ. 2 घंटा लग गया.
सर पंडित को पटाना था.
अरे पंडित को पटा के भी पैसा सही के भी हमने 2000 रुपया उधर दिए भी. और वो जो फाइनली वो जो वैल्यूड्रोम में जहाँ पे गए तो इट्स लाइक मारा मैं. मैं बोला भाई भूल जाओ. What I wanted actually basically है, you know, a monitor somewhere outside. If they're showing actually that is also good enough. Because it's risk. Right? हिम्मत जुटा के तो कुछ ना कुछ हम कर लिए पर disaster. Okay, this is what actually is a disaster, right? That is the reason you must know the capacity of the evacuation center. Let's say Dali there, then you know there will be no sanitation, there is no proper adequate facilities and everything. That will lead to another disaster. Flood coverage is इतना मरे नहीं होंगे, मुझे उससे ज़्यादा लगता है. Okay, so those data also you must understand. You are doing not your idea is not actually about the forecasting, but also the entire framework you should be able to develop. Okay. Now, then this is the part basically what you are learning in the entire 2 weeks. That means early morning and alert. Early morning is what? Long-term early morning, mid-term early morning, real-time early morning. When you are producing a list map, that is a long-term early morning. But when you are doing, let's say, bringing the hydrodynamic model, hydrological modeling, once the flood scenario is occurring, and also you are checking up with the water level, and then you are issuing the earnings, that is what you call real-time early morning. That means every 30 minutes, every 40 minutes, every 1 hour, that you are providing the early morning. Okay? So, and then there are different kind of products that you can prepare, like disaster map, forecasting map, okay? All those actually considered as the early morning and alert. Finally, this is not job, but your job is also to collect the data as a GIS person. Who is going to collect the data? Spatial database which you guys do. As a spatial analyst, a geoscientist, civil engineer, whatever, because you understand the data, the need of the data. So this is what also needs to be created so that these people can be able to use this data for command and control, mobilization, mission, planning, coordination, etc. etc. That means distribution of the relief centers, location of the relief centers, in the flood scenario, what is the shortest route, which route actually is the safest route. You know, all those information you can produce from your spatial data. Understanding now? If you understand this, more or less actually you can apply this technique in other type of visual applications. Okay. I have put actually some volume here. So this is the framework that we developed here. You see here, satellite-based acquisition. Also we took the flood operation data like from the telemetry stations. Then within them up, we develop actually meteorological, hydrological modeling, also the image processing. Then we are also estimating actually the water level values at different locations. Created entire the GIS database. Then we see that how the flood scenario will be changing. And depending on the flood scenario, obviously the committee, the disaster committee or national committee, coordination committee, the response team can be able to be dispersed. Always remember, when you are working on the research model, it's not just limited to research. What you have learned in the theory, when you go back to the real world, it's a totally different scenario. There is nothing but an idealistic scenario that you can be able to do. Everything as per you have learned in the theory. You've got to adapt. You've got to different ways of collecting data there. You can't think that, oh, this is the only way. No, no. The job needs to be done. Right? Time is short. Especially when you are working on a disaster domain, time is very short. Okay? Understand? This process flow. Some of these outputs, like you can produce like a flood susceptibility map like this. The red color shows actually the flood prone areas. Okay? You can also produce a flood risk map. Before flood risk map, you can produce a flood vulnerability map. We'll learn about it now. Okay? Then you can also produce flood extent map. Flood extent map is basically when you are doing actually the flood monitoring. What is the extent of the flood right now? How the flood has changed or moved. A scenario has developed from one or let's say the event has occurred about 10 years, 5 years, 6 years. How the flood extent has developed. Receding the water or what are the spatial footprint, right? So that can be also done using the remote sensing based data. Okay? So you see the backdrop I have put actually a satellite image and then I am showing the water bodies here, which are flooded, not the normal water bodies. You can see here this is the river. So the river I have not classified as a flood. Many people do the mistake. And during the monsoon time is a very tricky, You can't do it just simply a batch processing by thinking that, okay, this pixel value, when you do the classification, if it is beyond this threshold, I would consider this as a flood. No. Because during the flood, also, this is a blessing actually for the farmers. Right? They need that water. And that is not considered actually as flood. So that understanding has to be there. And that understanding has to be implemented through your analysis process. Okay? Then, flood affected area map. That means once the flood has happened, then also you can create a damage analysis, like how much area has been affected for insurance policy, how many hectares of land has been affected. Just overlay. That means flood, you have extended already not risk. Yeah, risk, but it's a qualitative. Qualitative. I mentioned, right? Risk, qualitative, quantitative. All theory I have already talked about. So you can say no more. Okay? Now this is a simple flood affected area map. Then this is flood emergency response map. It's a simple flood emergency map, the response map, but still it is very effective. For example, if this is the flood extent, okay, where are the locations of, what are the populations existing, okay, distribution of populations, where are the hospitals, you see here, hospitals, where are the nearest police stations, where are the evacuation centers, okay, and what are the capacities, what are the resources that they have, you can create into GIS database, right? Then, obviously the flood data. These sorts of information are very useful to take the decisions. Okay? Now let's look at a case study in detail. There is the Kelantan floods in Malaysia. This study area every year it gets flooded. People are so used to it. Okay? Alright. And you see, the situation goes like this. In Malaysia, you have two monsoons. One is northeast and one is southeast monsoon in a year. In India, we have one monsoon, right? So obviously, throughout the year, so there you have only one season or two seasons. One season. Throughout the year, the temperature is the same almost. In the excess of daytime, at night it drops around 20 to 25 degrees. Okay? Either you have sun or you have rain. Like in Kerala. Similar. There also they have monsoon. Yeah, that also. Okay. But it is so green for the year. Lush green. It's like, the trees are all being nicely painted or being colored. You won't find a dust to the tree. Here you go, it's dust because it's very dry. Right? So they have respected rainfall. Every day almost it will rain. Morning you will go, come back, afternoon there will be little rain. Okay? 400 mm is quite a lot. Average. Okay, now this also I have already explained, flood risk map. What is the flood risk map? Okay, why it is important? Damage assessment after the flood that has happened, then we would like to do some kind of quick damage assessment. Okay, objective of this particular study was to develop a flood risk model, to develop also flood damage assessment model, and to, okay, the field data. Now let's look at the study. This is Peninsula Malaysia, this is Sumatra, right? This is Peninsula Malaysia, this is here actually you have island. This is island. Krabi, Phuket, they are all here. This is Penang Island that I was showing you the other day, right? This is Langkawi, also a very famous island. Beautifully famous island for tourism, the duty free. Okay. So this is the state where every year it gets flooded, and this is the Pradhan, very long river, and it falls actually in the South China Sea. Okay. What are the data that we would need? Remember, any kind of objective that we are defining, the first important thing also, we have to understand what type. Then based on that, we have to develop the database. Okay. What are the data, in this case, because it's a tropical climate, okay, throughout the year, you have plenty of clouds. Very unlikely that you have a day where it's free of clouds. And during monsoon, obviously, because of the precipitation, there's a lot of clouds. So when there are a lot of clouds, your optical satellite data is almost useless. They slow them off. Remember I mentioned that, I think you have also, Professor Pasupuleti also has taught you, right? Active, passive remote sensing. The passive remote sensing is optical, is passive remote sensing is out. Okay? So therefore in this case, we wanted to engage radar images, which is an active remote sensing, micro remote sensing. Okay? Also we took other kind of data like landslides, especially for land use land cover. The radar images you can't use it for land use land cover. It's just one black and white image, right? That is good actually for flood mapping and all those kind of assessment, but not good for land use land cover. So this is a medium quality data that we do. Also, for a detailed assessment, we took it in spot. Spot 5 is basically this one. I think it's 5 meter or 4.5 meter. They have 4 bands, and one, the band chromatic actually has 1 meter. Okay, so one band is 1 meter, the other 3 or 4 bands actually has 5 meter. Okay, so then you can pan sharpen the image by fusing them, then you can make actually all the bands into 1 meter. Okay, then contour and spot height data, that is for topography, building the topography, distribution model, and so on. Rainfall data, obviously you need because we are dealing with floods. Topographic data also, watershed data also, population data, that is you need actually for your risk assessment. Then economic data. So obviously that I'm showing you, it's a very old project that we did, but I think right now here also it's very hard to get individual GDP data. Household income I think is very hard. First of all, I don't think if you have the detailed housing area data and ownership data, I don't think we have in India. Okay, you know, बहुत सारे सरकारी जगह पे तो लोग बना के बैठे, I don't think. I think there's proper land title that has to be given. Okay, so then when I mention socioeconomic data, depending on the availability of the socioeconomic data, at what level you can be able to do the analysis. Otherwise, you can do at a very high level assessment, either high level or you can go to very deep analysis as well. Software you use ArcGIS and last, depending on all kind of software does your job. These are the softwares you use. Recognition is very good for object-based analysis. Recognition. Okay. Then NV and also SPSS. Okay. Look at it. Although it looks very complicated, it's not. Break it down. This particular flow chart. Okay. Look at the different colors that I have put here. Boxes. Can you see the boxes? The blue one, sky color one, is the raw data. That means input raw data. Yellow one is the derived data from the raw data. Green one is the sum of the products that we produce, and the red one is the method or the model that we use. Now, if you look at actually the raw data, just now I mentioned already, radar sat image. From radar sat image, what you can get? Not extent. Because that's the only reason that we are taking the radar sat image, to derive the flood extent map, how the flood has been developing, or maybe you would like to see the historical flood locations, how the flood has spread over a period of time. Temporal radar sat images. Okay. So flooded area map or flood extent map also you can say. From contour and spot height, you can derive the digital elevation. From topographic map, you can also derive river and lake factor and all those things. Economic data, you can actually derive the GDP. Watershed factor map. Rainfall factor map. Landslides, land cover map. Then population data, population factor matrix. What we made actually the built-up area, because it's a very high resolution, so we wanted actually to classify the built-up areas. Any question that you have? See, this is how actually you design your framework from A to Z. Input data, raw input data, what are the processing methods and what is the output, then what kind of model that you're using, what are the input data going into that model and so on. I'll give you the source of spot file is French side. But in Malay, because it was a government project, so we had an undertaking with the French government and we could download the data for free. It's not free. Well, you can use, instead of spot, you can use IRS. So it's not actually, that you must use this data. It's just a sensor, I said. What are the sensors that we have used? So depending on what is the availability of the remote sensing, there are hundreds of different type of sensor and satellite data, right? In India, obviously, we would like to go for IRS data, which is almost free. For students, it's like even very free, cheap. Okay? Understand? Now, this is the model that we use, plot risk and plot risk model, and to develop the plot risk model, obviously, plot hazard and then plot vulnerability, both of them combined also plot risk. Now you understand the equations always? So that is why the outputs that we get. One is the hazard, that's the probability map, risk, different level of risk, vulnerability, different level of vulnerability. But in this case, we just took one vulnerability because we don't have that much of data. But when I will show you the earthquake vulnerability in Indonesia, we give the entire different types of physical, structural, all those things. Economic. Right? Now, that's why I'm telling you, you still can be able to do some assessment. But depending on what level that you are doing. Don't get stuck because of there is no data. Come up with the idea. Okay? Now, the last part is, once the plotted area map has been done, obviously that also needs to be verified. That has to be verified in the field and so on. And this remains as one of the input for training to prepare the plot hazard, right? As an inventory. Remember, this is the historical plot locations. This goes as an inventory. Then finally, we prepare the plot damage assessment as well. After the flood has happened, then you are collecting also some images to see that what is the area that has been damaged by putting in the built-up areas, other socio-economic factors and so on. Once we go through, you will understand more. Okay, clear?
Sir,
Yeah.
you just like to affected population or affected build-up?
Population is number of people. Built-up means how many houses?
So build-up to population damage cases.
How many people are under the flood? Let's say तुम्हारा गांव में 500 लोग हैं, तो अगर that is under the flood, you can say that 500 लोग actually अभी under the flood. कितना घर है? 300 घर actually under the flood, 200 houses in the flood. There are two different types of
Build-up was same type.
built-up means because you don't know. Why I say built-up? When I go to the next level of data classification, housing, that means you must also have the other classification, shops.
Oh.
Be smart. So I'm scientifically I'm correct. Because if I go to the next detail level, then it will demand you to classify each and everything. School, temple, masjid, industry, shop, pan dukan. How do you classify it? Do you have the data? If someone gives me now, this is the entire, obviously, I will go to that level. Are you all getting me? Okay, this I have already taught you many times. Risk is a function of hazard and vulnerability. This also I have already explained. Now, simple way. If I want to put a simple flowchart for risk assessment, raw data, pre-processing, create the raster test. Okay? Factor means conditioning parameters. You will understand. Don't each and every step I have to do very clearly for you to understand. Class 10 student also should be able to understand. If you guys can understand, I will keep you. Okay? Develop a model, then you do the evaluation. So forget about it. Let's go to the next one, step by step evaluation. Now, question comes, what is a factor system? Okay? Our main goal, ultimate goal is to produce a cloud risk map. Okay? Pay attention to it. And now with that, now we know that risk map is a function of hazard and vulnerability. So it's a function of hazard and vulnerability. See how I have broken it down. Okay? Now, to produce a hazard map, based on the input data that I have, what are the parameters that it goes in? Landfall, land cover, terrain data. Again, high level classification I am doing. Okay? Then watershed data and river data. Correct? Again, if I go to the next level, what are the information that we need in rainfall data? Okay? Antecedent rainfall. That means 3 days, 4 days, 5 days. Rainfall doesn't have, I mean the plot doesn't develop just unless until it's a flash plot. That's why I define flash plot. Otherwise, it's not 2 hours of plot. Your house is not getting flooded. Unless actually तुम लोग पूरा सब कुछ, drainage सब कुछ बंद करके रखे हो. ठीक है? Then that is also called a storm. Here I calculate a storm because it's coastal and that area is very prone to storm, especially during the monsoon. But again, this factor whether we could include it or not, depending on the study. Right? अगर झारखंड में कर रहे हो, storm ना. Right? Are you all with me? Land cover, obviously simple land cover. Terrain, what are the terrain data? Deceleration model, slope, LST. Okay, LST means relief, land surface deviation. Land surface deviation basically the deviation of the land surface in terms of relief, in terms of slope, in terms of aspect, in terms of curvature, and so on. You can take all these parameters here as well. Okay. Then you have watershed, that means the watershed areas. Then you have river, distance from the river and density of the river. Okay? How I have broken it down, objective. What are the actually inputs for the objective? Then what are the input data should go into each of those processes. Are you with me? Similarly, for the vulnerability map, I need socio-economic data, right? One is population, another is economic. These are the only 2 data that I have. Okay? And that is also very large scale I have. So population is population density and economic is the GDP. Gross domestic product. Okay? Now, pay attention to this. What I explained to you, I put it here. This is the ultimate goal. Level 1, level 2, level 3. But you produce on level 3. But you can only understand once you design your framework. Once this is done, everything can be used. So when I do my MTech paper, the subjects that I teach, I ask this kind of question. No short time, like I give a problem, and being now, because you are going to be expert in the field, because masters of PhD, this is the problem that I have. I'm running, let's say I'm the head of the council. Now this is the problem. I have about this much of dollar value money and I want to solve it. Please, being an expert, please solve it. I won't ask a question what I have taught in the classroom. What is the resolution of Spotify? What are the bandwidth of red band? That you can talk. So 1 second you can find out. I want you to think. Problem is different. How you can apply. Okay? And I give 4 questions. 5 questions. 4 out of 5. 4 is any 4. Okay? Each of them will carry 25 marks. That's all. So think of applied base. Now, let's go to the next level. What are the data that we pre-processed? For the flood area extraction, we took the previous flood records. Okay? The previous flood records in 90s, 2000, early 2000s. All the floods that was happening in the past. So we collected the data. Okay? And based on those events, we decided what is the duration of the radar image that you should capture. Because there was no inventory whatsoever. Obviously there is an inventory, newspaper, they would have reported. So that actually information also helped us. Okay? Because most of the newspaper they would put, this area is flooded, but you do not know the spatial. This village was flooded. I mean the village, what is the spatial footprint? But in GIS, it demands you to have spatial footprint and scale. Real. Not correct, right? Accurate to number. Because remember, this is all data-driven approach. In any expert को बोलोगे तो कैसे करेगा?
मेरे पास वो पॉलीगन वाला डेटा है 35
पॉलीगन तो लेना जरूरी है।
उसका एक्सटेंशन है ना एक विलेज एक ब्लॉक टोटल यूनिटी नहीं हुआ उसका
Yeah,
पर्सन
exactly what it is. So, I am going to show you what exactly scientifically you must know. Okay? So, flooded area, we took actually first, depending on the report, whatever reports we have, 40 years of data, which is all kind of reports we try to research. Okay? And then we got the information, oh, there is a massive flood that happened in 1992 or 93. What time? Then we look at actually the inventory of the radar sample, archive. Then we took that image and processed it. We developed actually the method so that we can derive the flood area map, flood extent. Okay? Understand? Rainfall. Based on actually the event that you have taken, the corresponding rainfall data is also taken. Because that precipitation would have caused that flood to occur. Right? That is why that corresponding rainfall data, that the triggering factor you must take into consideration. Okay? Land cover classification, that's okay. Land cover doesn't change much unless it is a city. But in the rural area, it doesn't change much. Okay? Built up area extractions from the spot. High resolution. Let's put high resolution. Anything. That time if I had iconos, I would have taken iconos. Which point? 0.6 meter, I would have taken 0.6 meter. Population density, you can get those data statistics department in India, I don't know who is the GDP, again maybe economic unit, the government of economic unit, I don't know what they call. Watershed extraction, that you can do based on actually the topographic map. In GIS you can be able to do that. Terrain information, also topographic map in this case. But nowadays you can also have high quality VM, LiDAR, whatever you have. Slope, then LST, all that. River information extraction, you can get it from the distance and the density you can do it based on the river. Okay, clear? Flood area extraction from the radar image. What is to be true? The data is the radar image, let's say during the flood. Right? I told you that given particular event, during the flood, we took actually the as many as number of radar images, depending on how many passes, how many temporarily it is available. We took the GCP. The obvious for ground control points, there is no ground control points. Yes. Why do you know ground control points? Because the image needs to be geo-rectified. And also the GCPs are useful for training the sample as well. Training different classes and all that. It's called GCPs are for ground control points, which has to be homogeneously distributed throughout the field. Okay? Then we took in these cases data software, different processes obviously you have to do, but image treatment that you have to do. Noise reduction, geometric correction, then projection, bringing to the right projection, right? You have done one exercise, but not with this software, not with this image, but other kind of image you have done, right? Then we calculate it here threshold values, because remember, it's all about the pixel value. But in the radar, you are talking about the backscatter coefficient. Radar works in a totally different way than regular image. The optical image, basically you have the distal number value or pixel value, okay, or grade level values, you can tell that. But in radar, you have actually the backscattering coefficient, delta, sigma naught. It's called sigma naught. Okay. So we wanted to estimate and come up with a threshold value that distinguishes between water and non-water. Because radar is very sensitive to the water phase. We wanted to automatize the process, because remember, just one event you might have 7-8 images. Okay? Now if you are, let's say, going to have multiple events, 30-40 events in the last 30 years, and you have there's hundreds of images, you are going to do it online one by one resources. क्या एक आदमी को बैठा दोगे 3 महीना तो यही करता है. So we wanted to automatize the process, build a model, all batch processing activity. Are you understanding? Okay. So threshold value we come up with. Now, what are the processing techniques that we do? First is mountain shadow, because mountain shadow also appears to be very dark in the radar image, which mistakenly can be considered as a water. The shadow of the mountain, because the way the data has been captured, right? The look angle, right? So let's say there is a mountain here. If the data has been captured here, you have a shadow. So the shadow, the backscattering values of this, the shadows and the water bodies could be very similar. So you got to make sure that thing is being corrected. So what then mountain shadows data set. So all this process was done in GIS. Then finally we distinguish between what is the normal water extent during the, let's say, monsoon time. That means rivers should be excluded, paddies should be excluded, lakes and all water bodies should be excluded because they are not the flood water. Right? That's the reason I put normal water extent data set. After putting that, based on this threshold, then we calculate the flood area, flooded areas. Okay? Then finally we come up with the flood area. Sounds to be very simple, but obviously it's a lot of digital image processing, research and everything done. In my early papers, some of the papers maybe I would have published on this subject, I don't remember. 900 papers is very hard to remember. Okay?
Sir?
Yes, sir.
Sir?
Yes.
Threshold value, are you talking about histogram classification?
Yeah, histogram classification you are talking about in especially optical image. But there you don't call, histogram. You check what the histogram is. Yes. In optical image you will go with the digital number, value the separation value, right? Essentially it is histogram. Okay? Alright? Let's look at how we did. See here. There are 3 major events. We took temporal data and you see all those data was fed into the model that we developed. Then automatically it calculated just the flooded water bodies. And you can see with the time, you see the dates are changing, right? See the dates are changing, and how the flood is being developed and spread based on the radar. Your life will be much more easier if you have optical images. Okay? Because in physiology also can have a lot of this. Radar images are very boring to deal with because they are black and white. But they are very useful. Accurate. Okay? Can you see? So this is what is my inventory. I had no inventory from scratch. I developed now my inventory. But I also made sure I send my team to do field evaluation. I'll show you that how we do the field evaluation. Using DCPs, go to the field, different areas you go, साल में ऐसे हुआ था not that information also useful. Otherwise, how do you will this? Plot तो आता ही जाता, right? You are talking about 30 years old data. Participating modeling, that is why it is. Okay? Community. Feedback from the community is also very very important. ऐसा नहीं कि तुम अपने लैब में बैठ के अपना फ्लोर मैप बना दिया और बैठे रहे बोलो कि दिस इज व्हाट इट इज पूरा ये गीता बन ऐसा नहीं I wouldn't trust anything. All see, after all, someone is collecting, right? It's also human error. For me, before I process, I have to be confident with my data. Because so that if anyone asks my output, I am not going to give an excuse saying that, "अरे वो तो डाटा में वहाँ से लिया था, और उनकी गलती है." Scientists, you must do that. Validation. For data acquisition. You understand the different ways how you can capture the data. Right? It's like a PhD, तो 5 साल मिलता है. Guys are 5 years. I finished my PhD students in 3 years. Now be spot on. From day one. यहाँ पे तो मैं देखो 1 साल से पता नहीं चलता है करना क्या है. कई सारे बच्चे मिल जाते हैं. सर मुझे ये भी करना है, वो भी करना है, ये भी पसंद है.
एक साल तो सर क्लास करना पड़ता है. कोर्स
Okay. Now, see these are the different radar set images that we do. What are the date? What is the resolution? What are the threshold values we come up with? Okay. We automatize the process because we wanted to do the batch processing, right? So we build a model in ArcGIS so that it takes the input data, then it asks you the input data, then just 1 or 2 steps in between just to cross check, and then it gives you the output. But you can also 100% automatize. Like I have built a system for Brunei government, which is totally automatized because they don't want to know in the back end of the machine what is happening, what the model is doing. They just want to see a nice, wonderful, very simple graphical user interface. Okay, so that input data. That also they want, sir. Is it possible the input data is coming from G source? Can you please download the data, automatize the process so that we don't have to do that also. We don't want to click in and select the input data. Everything is done automatically. That's what we have done also. The one system we developed, the Southeast Asia Fire Danger Rating System, used by the Malaysian Meteorological Department. Everything is okay. The NOAA, MODIS, all data automatically we are selecting, processing. If you've got time, I can share with you. Excellent. I was millions of dollars of project.